Assalamualaikum warahmatullahi wabarakatuh dan salam sejahtera kepada semua yang menonton RBTX Clinics pada petang ini. Apa khabar semua? Saya Muhammad Kamal Gadri daripada Petroscience sebagai moderator anda petang ini. Sedar tak sedar kita sudah sampai ke penghujung episod dan episod ke-8 petang ini adalah final episod RBTX Clinic 2021. Jadi terima kasih kepada mereka yang dapat bersama kita pada petang ini. Kalau kita imbas kembali episod 1 sehingga episod ke-5 RBTX Clinic, kita bersama dengan pakar robotik kita Cikgu Zul, ya, iaitu Dr. Zulkifli Mahmudin dari Uni KL BMI Gombak. Dan pada episod ke-6 RBTX Clinic 2021 kita bersama pakar robotik dari UIA Dr. Zulkifli Zainal Abidin, ya. Dan minggu lepas kalau anda ingat lagi, kita bersama pakar robotik dari Universiti Malaysia Pahang, Dr. Nurul Hazlina Nordin. Untuk petang ini, petang episod terakhir Robotik Clinic 2021, kita akan bersama seorang lagi pakar robotik yang telah bersama-sama Petroscience sejak dari 2016 lagi, yang membantu kami membangunkan program robotics di Petroscience, terutama untuk RBTX challenge ini, dan sebagai penasihat dan juga trainer kepada kami juga. Beliau adalah pakar jemputan kita pada petang ini adalah seorang pensyarah dari Universiti Islam Antarabangsa IIUM. Beliau adalah Profesor Madya TS Dr. Yasir Mustafa, iaitu pensyarah Mekatronik dan Engineering Department Kuliah dan Engineering IIUM. Dan beliau juga adalah Director Makerspace Center for Unmanned Technologies IIUM, juga Head Area Robotic Laboratory Center for Unmanned Technologies IIUM. Apa khabar Dr. Yasir?
Assalamualaikum, salam sejahtera Encik Kamal. Baik, alhamdulillah.
Terima kasih Doktor kerana sudi bersama kami pada petang ini. Walaupun kami tahu Doktor sibuk dengan tugasan Doktor, tapi dapat meluangkan masa juga petang ini. Minggu lepas kita bersama dengan Dr. Nurul berkongsi ilmu dan maklumat tentang Robo Sumo, iaitu satu kategori di dalam RBTX Challenge 2021. Jadi petang ini Dr. Yasir akan meneruskan perkongsian ilmu tentang Robo Sumo, ya?
Ya.
Okey. Jadi sebelum itu untuk peserta ataupun penonton RBTX Clinic petang ini, kita harapkan jikalau ada sebarang kemusykilan ataupun soalan, silalah anda tuliskan di ruangan chat ataupun boleh angkat tangan ataupun raise hand, ya. Dan pihak kami akan cuba menjawab soalan-soalan ataupun sebarang kemusykilan daripada anda. Dan untuk reminder juga, di akhir sesi kita, kita mohon kerjasama setiap penonton atau peserta RBTX Clinic episod 8 ini untuk mengisi evaluation form yang akan disediakan dan QR code akan diberikan di hujung rancangan nanti. Jadi Dr. Yasir dah bersedia?
Okey, boleh, insyaAllah.
Boleh, ya?
Boleh.
InsyaAllah. So Doktor, silakan.
Okey, Assalamualaikum warahmatullahi wabarakatuh dan selamat sejahtera semua penonton, partisipan RBTX 2021. Okey, seperti yang Encik Kamal terangkan tadi, nama saya Yasir Mustafa, dari Universiti Islam Antarabangsa. Okey, dan memang minat memang dari awal lagi tentang robotik, dan alhamdulillah diberikan peluang untuk bekerjasama dengan Petroscience untuk meneruskan research dan juga penyelidikan dan juga memberi advice dan nasihat kepada Petroscience mengenai robotik. Okay, terima kasih atas peluang yang diberikan kepada Petroscience, dan juga saya ingin merakamkan setinggi apresiasi kepada Petroscience kerana usaha yang berterusan dalam mengembangkan sains dan teknologi lah, STEM, pendidikan STEM ni di dalam negara Malaysia dan juga seluruh dunia. Okay, dan saya harap usaha ni dapat diteruskan dari in the future lah, masa-masa akan datang.
InsyaAllah dengan sokongan Doktor.
Kita dapat tengoklah memang dunia berubah ke teknologi, ke sains dan teknologi. Okay, pada sama kita belajar sains, betul sains juga menerapkan nilai-nilai lain, etika dan professionalism. Semua ni penting dan patut dipackagekan lah. Dan saya nampak usaha Petrosains sangat cantik lah dan sesuai untuk negara Malaysia especially. Okay, so hari ni kita akan teruskan daripada minggu lepas punya session, berbincang mengenai RBTX 2021 kategori Robo Sumo. Okay, dan saya akan sharekan skrin sebentar. Okay, dan slide. Okay, dan sesi kali ini kita akan fokuskan kepada Robo Sumo lah, especially Robo Sumo. Okay, dan hopefully kita dapat tengok satu lagi sensor baru yang tak dibincangkan ataupun tak didemonstrasikan dengan detail last session. Untuk kita tengok itu sensor ultrasonic, macam mana kita boleh guna ultrasonic untuk Robo Sumo especially. Dan kemudian kita juga akan tengok balik robot motifs, okay, dan macam mana kita boleh program motifs untuk kategori Robo Sumo ni, dan juga bagaimana kita boleh guna ultrasonic di atas Robo motifs. Dan kemudian kita akan tengok last sekali lah, mungkin part yang paling complicated sekali, kita nak tengok macam mana kita boleh buat coding, text based coding guna Arduino IDE.
Oh, petanya ada coding Dr. ya?
Ada coding. Kita akan tengok macam mana coding. Tak nak guna M-block, kita nak guna Arduino untuk programkan motifs.
Okay. Syntax.
So mungkin session tu complicated sikit lah, cuma kalau macam ada soalan boleh ditanya lah. Sebab kita nak tunjukkan yang robot motifs dan kebanyakan robot yang lain, dia microcontroller atas robot ni dia boleh diprogram dengan banyak sangat cara dia lah. Dan traditionally kita guna line based coding, okay, text based coding. Dan kemudian baru ni dengan usaha STEM ni kita perkenalkan banyak GUI based coding yang di mana kita drag and drop macam M-block. Tapi if you want to go advanced, kita kena kembali kepada text based lah. Sebab GUI ni feature dia currently agak limited. So kita tengok that feature at the last part of this presentation.
Okay, menarik ni Doktor.
Okay, alright. So simple flow of the session. Okay, mula kita akan bincang sedikit recap kembali mengenai Robo Sumo, dan kemudian kita tengok design robot sumo, dan kemudian kita tengok sensors yang dipakai di robot sumo, simple je sensor-sensornya, dan finally kita buat hands on sikit macam mana kita boleh program motif robot. Okay. So untuk RBTX 2021, okay, untuk Robo Sumo kategori, kita ada dua subkategori, di mana kita ada kategori junior dan kategori advance. Okay, ada sedikit beza antara rules kategori junior dan kategori advance. Okay, di mana junior bilangan objek yang robot perlu tolak tak sebanyak kategori advance. Okay, kerana untuk kategori junior, the target participant ialah pelajar-pelajar dari sekolah rendah 6 tahun hingga 12 tahun. Okay, target age group. Dan kemudian untuk kategori advance, dia punya target is for pelajar sekolah menengah, sekolah secondary. Okay, dan age range ialah daripada tingkatan 1 13 tahun hingga ke tingkatan 5 17 tahun. Okay, untuk Robo Sumo, sebelum kita menyediakan robot, kita perlu sediakan dia punya padang, field ataupun ring sumo. Sebab sumo ni main atas gelanggang ataupun ring, okay? Dan ring pada tahun ni kita setelah modify supaya participant boleh print je. You can print atas kertas A0, dan kemudian bila print tu you akan dapat the exact scale of sumo field yang boleh diguna pakai untuk pertandingan RBTX Robo Sumo. Okay, so boleh download di link berikut, okay, Robo Sumo PDF, dan kemudian print atas kertas A0. Okay, kemudian untuk objek yang robot kita kena tolak, sebab normally bila kita bincang Robo Sumo ni, bila bercakap pasal Robo Sumo, normally kita ada dua robot tolak lah, macam game sumo yang sebenar lah. Game sumo kan ada sumo wrestler tolak sumo wrestler yang lagi satu.
Ya, tolak lawan.
So untuk yang ni robot tolak robot sebenarnya lah untuk Robo Sumo kalau yang masih baru, tapi saya yakin yang ramai di sini tahulah Robo Sumo tu naturally macam mana. Tapi untuk tahun ni kita sebab online kan, mode kita online. Virtual. So because of COVID, unfortunately we have to adapt lah to this new condition. Tahun ni kita buat virtually. Okay, but competition virtually still, I think the impact is the same. You still get to learn how to build robots. You still get to enjoy, hopefully, building the robots and try to design the best performing robots, etc. Okay, so untuk tahun ni dia tak tolak robot, dia tolak cube. Okay, kita kena buat cube sendiri, DIY cube, where you can print this design RBTX cube.pdf dan kemudian print on A4 paper. Okay, lepas print on A4 paper tu kita nak, kalau boleh kertas yang tebal, okay, macam cardboard paper ataupun kertas A4, and then you can paste on thick box ke ataupun thick paper, and then you cut according to the outline. Lepas tu kena lipat, buat origami sikit, gum sikit, dia akan jadi cube macam ni, cube je. Okay, you'll get cube like this.
DIY lah doktor kan?
DIY. Memang kena potong lepas tu gum jadi cube. Okay, so robot kita kena tolak cube ni. Untuk junior you kena tolak 3 cube, dan untuk advance you kena tolak 5 cube macam ni. Alright, so that's sumo kategori tahun ni. Dan
penambahan doktor, untuk penyertaan masih terbuka lagi untuk masuk pertandingan RBTX challenge, virtual challenge competition. Kita hari tutup kita dah 15 Oktober 2021. Masih ada masa lagi.
Ya, betul. Boleh register lagi. And then itulah tahun ni sebab dia tak berlawan dengan robot lain, mungkin lagi mudah lah, lagi mudah di plan. Robot yang kita design lagi senang buat performing robot. Kita tak ada unexpected punya factor, tak ada robot lain tu kacau robot kita kan. So hopefully you can do very well dalam Robo Sumo tahun ni lah. Tapi hopefully it improves your robot supaya dia lagi versatile, dan maybe in the future next year ke boleh join robot yang robot lawan robot tolak robot.
Ada soalan doktor?
Oh, ada soalan ya.
Apakah material fill yang sesuai untuk digunakan?
Okay, untuk fill, you can print on any A4 paper, tapi kalau boleh yang tebal. Yang tebal dan surface tu jangan berkilat. Okay, kalau berkilat nanti your sensor might have problem. Macam paper yang saya dah print ni, dia berkilat sikit. So line sensor tu dia tak berapa sensitif. So you cari surface paper yang surface dia tak berkilat, matte surface yang tak ada reflektif sangat, supaya the light from the IR tu dia boleh absorb 100%. So any paper kalau boleh yang tebal supaya tak koyak lah. You can always sebab dia dah printed, the scale should be up to the scale yang kita design, and then kalau macam ada smudge sikit tu you boleh padam atau you boleh conteng balik dengan marker hitam saja. Tak ada masalah. Paper the track can always be maintained lah lepas you print.
Yang penting jangan koyak.
Paper yang durable lah, paper durable lah.
Jangan koyak kan doktor?
Betul lah, jangan koyak lah.
Doktor, ada soalan. Di dalam rules ada dinyatakan berkenaan berat bagi objek cube. Jadi doktor boleh terangkan kenapa diletakkan sebegitu di dalam rules dan adakah ianya wajib?
Okay, untuk objek ni kalau you buat dengan kertas A4 yang nipis kan, nanti objek ni kalau you letak mungkin kalau kena tiup angin sikit dia terbang, ataupun bila your robot lalu tepi dia mungkin dia tertolak sebab angin tau. So that's why we put this minimum weight supaya bila robot tu lalu tak tergerak lah, ataupun ada angin ke macam bertiup ke, and then mengacau objek tu punya position dan kacau performance of your robot jugalah. So we put minimum weight punya requirement, dan dia punya basis is kalau you print on A4, normal A4 lah, nipis ke tebal ke tak kisah, and then you tampal dekat kertas cardboard. Okay, kalau tampal dekat kertas cardboard yang agak tebal, then you would achieve that weight yang kita specify, which is berapa, 5 gram
Plus minus 5 gram lah. Tapi pokok pangkalnya bermakna Dr. Yasir objek cube tu perlu mempunyai sedikit berat lah. Rasanya tidaklah semestinya diletakkan apa-apa objek di dalam. Tetapi mungkin ketebalan kertas yang digunakan tu sendiri akan memberikan sedikit berat ya Doktor?
Betul, yes.
Okey.
Kalau
Baiklah.
yang
Kreativiti masing-masing.
Guna kotak-kotak yang dah terpakai ke, you boleh guna balik untuk buat cube-cube ni.
Mengikut kreativiti masing-masing doktor kan?
Betul.
Untuk mencapai berat yang kita kehendaki.
Betul. Okey, ada soalan lain? Tak ada. Okey, kita
Boleh
continue.
teruskan.
Tak ada lagi setakat ni. Terima kasih Doktor.
Okay, thank you. So kita continue. Kalau kita print field, okay, we will see this. Okay, kita akan nampak ada ring, ada kotak measurement dan logo-logo yang cantik ni lah. Okay, kalau kita tengok the field, okay, yang elemen yang memang kita clearly nampak ialah bulatan hitam ni lah yang kita panggil ring, the ring of the sumo. Okay, ring ni size diameter dia lah dalam 70 cm, okay, dan bila you print you akan dapat that exactly that length lah, diameter macam tu. And then dekat tengah ada shikiri line, okay, warna coklat yang gelap, nombor 2 ni. Dan kemudian nombor 3 kita ada object placement, okay, banyak object placement spot lah dan berlabel A, B, C dan seterusnya. Okay, pada ketika competition nanti dalam round-round yang hujung grand final nanti, position of object kita akan randomize kan. Okay, kita akan letak dekat spot yang tidak diberitahu ataupun tidak di-reveal kan. Okay? Dan apa yang kita nak ialah capability of your robot untuk detect sebab kalau kita main sumo, robot opponent bergerak kan. So kita tak tahu, kita kena detect kat mana opponent punya robot. So sama juga untuk sumo ni, untuk bagi dia punya randomization tu ataupun untuk test the capability of the robot untuk sense, kita akan randomizekan position of the object. Okay, objek ni kita akan randomkan lah, letak mungkin dekat I, mungkin dekat F, yang akan di-reveal later. So you have to design a robot yang boleh sense objek. Okay, dia boleh sense dia kat mana dan dia boleh sense sama ada di atas ring atau tak, dan juga dia boleh sense objek tu dekat mana. Okay, dan size robot kita just tengok lebar dan panjang, okay, 15 cm kali 15 cm. Dan kalau kita print, you can just test your robot dalam measurement box tu lah. Sebab measurement box ni kalau kita ambil pembaris, kita ukur, memang sini 15 cm. Okay. So kalau dia tak 15 cm, that means something wrong with your printing, you can buat adjustment sikit.
Maksudnya doktor, robot kita tu kita untuk test sama ada mematuhi peraturan, kita letak dalam petak.
Betul.
Tersebut.
Kita letakkan dalam petak tu.
Okey.
Lepas tu cube pun kita letak dalam yang kotak ni, kotak kecil ni. 5 cm kali 5 cm. You boleh letak cube you dalam tu untuk measure dia 5 cm kali 5 cm atau tak. Okay. Okay, so sepanjang pertandingan, okay, robot kalau kita baca rules, robot tu kita perlu design bila kita tekan button kan, bila start of the game, you bagi signal kat referee, cakap referee saya nak start, you tekan button dan kita akan start timer. Okay, kita akan startkan timer. And then your robot kena stop 5 saat lepas tu baru dia bergerak. Tapi time dah start lah, time dah start bila you tekan button tadi. So 5 saat tu memang 5 saat yang robot tak bergerak dan kemudian dia akan jalankan tugas dan tolak semua objek. And untuk Robo Sumo, kita akan tentukan pemenang ikut siapa yang paling laju tolak all the objects. Okay, kalau you tolak objek dengan paling laju, then you will be declared the winner.
Maksudnya tolak sehingga habis doktor ya?
Betul, tolak semua objek sehingga terkeluar. Dan pada masa yang sama, robot tak boleh terkeluar. Kalau robot terkeluar sepenuhnya daripada ring, okay, dia terkeluar sepenuhnya daripada ring, dan kita kira round tu habis lah sebab robot sudah terkeluar. Okay, so kalau robot terkeluar, kita akan kira berapa banyak objek yang telah berjaya ditolak dan kita akan rekodkan masa sebagai 1 minit lah, masa paling panjang. Okay, so tu mengenai field ataupun ring untuk Robo Sumo. Okay, next kita tengok pula on the design, robot design. Okay, Sumo robot ni banyak sangat design dia. Okay, bermacam-macam. The Sumo robot is a very popular robotic games lah, yang normally kalau kita tengok dekat competition mana-mana, you will see Sumo robot. Because of the simplicity and also the exciting excitedness bila robot tu menolak each other lah, dia ada macam perlawanan sikit kan. So over time people have come out with different design of Robo Sumo. Okay, kalau tengok traditionally, kalau macam game yang robot tolak robot, okay, people will normally go with design yang ada shovel. Robot tu dia ada macam shovel dekat depan dia untuk songket robot yang lagi satu, untuk angkat robot yang lagi satu supaya grip of the robot tu lost. The robot lost grip dan kemudian mudah ditolak lah. And so normally you'll have like blade kat depan ni untuk congkel ataupun untuk shove the other robots. Okay, pada tahun ni sebab design dia berlainan virtually, kita perlu just tolak objek yang tak berapa berat. Okay, so maybe the design could be simpler. You don't really need this advanced design lah. Okay, as I said, this year could be your training ataupun your preparation untuk next year where you can battle another robots when hopefully thing goes back to normal next year. Okay, so we have had Sumo robot, okay, several years, 2 tahun lepas RBTX we have Sumo, and then year before pun kita ada Sumo juga, and you see different kind of robot design. Okay, ada yang buat guna Lego, okay, different design of Lego Sumo robots, and then ada yang buat from scratch guna Arduino, okay, guna Arduino and Moto, they combine and they assemble their robots. Okay, and we see different creativity lah. Okay, at the end of the day, this design really plays an important factor untuk decide kita menang atau tak. So you have to give some thought about it lah. So tahun ni design factor is not that critical, but you have to have a good programming. Macam mana robot tu boleh bergerak dan tolak objek dengan cepat. Okay, so you have different design. Okay, kalau kita tengok from our earlier workshops, we have been talking about satu robot, nama dia Motif. Okay, robot Motif ni can also be used. This year kalau kita lawan semua dengan robot Motif, tak ada masalah. Sebab tak ada robot yang macam ni, robot yang ada shovel ni tak ada, nak shovel dia lah. So you can actually use Motifs for this year Sumo robot, Robo Sumo kategori, sebab dia just tolak objek. Okay, and you can do very excellent programming kalau boleh on Motifs, dan you can actually push the objects very quickly lah. Okay, and internally kalau kita tengok design of this robot kan, kita tengok dia ada wheel, and then dia ada the chassis, the body, and also nampak elektronik sikit tu is the internal lah, dia punya the brain, the microcontroller, and then dia punya motor driver and all those other sensors semua kan. So what are there inside the robots actually? Kalau kita tengok this block diagram, okay, the main part of the robots, any robot actually, is the microcontroller or the microprocessor board. Okay, this is where you put in your programming, your instructions semua masuk dalam ni. Dan microcontroller ni akan execute your codes dan bergerakkan lah, that define the behavior of your Sumo robots. Okay, and microcontroller must be connected to a motor driver untuk drive the motor. Kalau kita tengok Sumo robot yang ni kebanyakannya, okay, you normally have 2 wheels. Okay, 2 wheels. Yang ni pun actually 2 wheels, cuma dia expandkan the 2 wheels to become 3. Okay, and what happened is this 2 wheels robot, we call it the differential drive robot. Okay, you define the kinematic of the robot, kita define ikut the spin of the 2 wheels. Okay, dua-dua pusing ke depan dan you ke depan, dua-dua ke belakang. Kalau you nak turn, satu ke depan, satu ke belakang, ataupun satu slow, satu laju. Then you have different kinematic lah. And that's what you have to program dalam microcontroller, and then microcontroller will will give the signal to motor driver, dan motor driver akan control the voltage and current to the motor that define the speed. Lepas tu this microcontroller must be powered, okay, must be powered by batteries, and sometimes because battery normally high voltage, and microcontroller operates at lower voltage, so you need a power regulator or power supply system that can supply power to microcontroller as well as the motor driver. Sebab motor driver will pull voltage or current directly from battery to the motor according to the signal from the microcontroller. And then most important one is the eye and the senses of the robot. Okay, untuk robot sumo, okay, you have to detect whether you are on the ring or not. Okay, kalau nak terkeluar ring, you kena cepat-cepat masuk, sebab kalau terkeluar you kalah. That's the most important rules of sumo. Okay, dan juga untuk effectively fight your opponent ataupun effectively push the objects, you have to have a sensor to detect the obstacle ataupun the object ataupun the enemy, okay, the opponent. Dan normally the sensor, okay, the sensor could be different kind of sensors. There are different kind of sensors that can use for line sensors and the obstacle or enemy sensors. Okay, kalau you nak design your robot guna Arduino, normally what we will use is yang paling popular sekali, Arduino paling popular is Arduino Uno. Okay, kalau you nak guna Arduino Uno lah, Arduino Uno ni can be connected to motor driver. Okay, this L293D ni also very cheap, low cost motor driver, but very useful, okay, and quite durable as well kalau kita control dia punya voltage range and current range. And then this motor driver is connected to a motor, okay, compatible motor that fit the voltage range of L293D or the motor driver that you chose. And also all this must be powered. Okay, sometimes we want to use separate batteries for the motor driver. Okay, kita nak bagi high voltage to the motor and we want to give a lower voltage to the microcontroller. So you can use different batteries if you want.
Biasanya motor driver yang banyak menggunakan power kan, Doktor?
Betul lah. Kalau kita tengok this microcontroller, dia pakai current very low current lah. Macam milliamp lah paling tinggi pun, ataupun micro ataupun a few hundred microamp lah. Motor ni bila dia berpusing dia akan pakai banyak. Dia akan pakai macam 1 amp, okay, could be 1 amp kalau motor tu kuat, 3 amp kalau motor tu very strong, okay, or could be 0.5 amp kalau motor-motor macam ni. So this really drive dia tarik banyak current lah, and really eat the battery life. So yeah, you can have a good power management as well, power supply management. And kemudian sensor, okay, for line sensor normally we'll use IR type sensor untuk detect the surface. Okay, and then for the obstacle sensing, okay, popular one would be this ping sensor or ultrasonic sensor, dan juga sekarang ramai juga yang pakai laser ataupun forward facing laser ataupun forward facing IR sensors ataupun light sensors untuk detect the object in front. Okay, tapi all these sensors have different specification and requirement, and also dia punya detection distance tu pun different lah. So we have to really define ataupun really select which sensor is best suited for our robots.
Doktor nak tanya boleh?
Yes.
Okay, untuk Arduino Uno ni berapa banyak sensor kita boleh pasang?
Okay, Arduino Uno, if you look at the pins, dia ada 0 to 13, okay, digital pins, dan juga you have this analog compatible. It's also digital compatible dan can be used as analog input pins. So all these pins can be used to connect to a sensor. Okay, some sensor ataupun most sensor requires only one pin. Kalau digital sensor lah. Okay, kalau sensor macam ultrasonic ni requires 2 pins. So yeah, it might according to the sensor requirement juga, okay, that would limit the Arduino Uno board punya sensor, number of sensors lah. But at the same time, you need these pins for motor driver, which is quite a number of pin juga. Okay, which also would reduce the number of sensors that you can put on your robot. Tapi cukup lah, it's quite popular Arduino Uno being used for sumo robot.
Boleh untuk 2 sensor kan Dr.?
Ya, 2-3 sensor, even 6-7 sensor boleh juga.
Minimum 2 sensor.
Yes, minimum sensor would be the
Robo
line
Sumo.
ataupun the surface, black or white sensor.
The obstacle.
And the obstacle in front, satu kan. Okay, so next we'll talk about the sensor. Okay, first sensor is the surface sensor, black or white kan. Okay, why you have to print on matte surface tadi? Sebab the sensor that detects whether it's black or white really depends on this reflectance of the surface. Okay, white surface or reflective surface, they normally reflects most of the light. Okay, sensor ni how it operates, dia akan pancarkan lights, okay, from this transmitter, we call it the IR transmitter. Okay, IR light is an invisible light that you cannot see. Okay, tapi itulah, but this receiver, okay, ataupun this IR sensor, this is the IR sensor. This IR sensor capable of detecting the IR lights. Okay, so when we transmit these IR lights out of this transmitter, okay, normally the IR punya LED, IR emitting diodes, they emit these IR lights. Okay, these lights will bounce off this white surface or being reflected by normally the white surface, which will reflect a lot amount of IR, and this reflected light will go back to the sensor. Okay, bila sensor to detect the presence of IR light, then it knows that it is a white surface. Kalau black surface, dia akan absorb all this light, including the IR lights. Okay, black surface absorbs all lights. Okay, even the light yang kita tak boleh nampak, the IR, the UV, dia absorb. Okay, and when this IR lights is absorbed by the black surface, it will not be reflected back to the sensor, the IR sensor ni. So the IR sensor will sense nothing. So dia cakap, okay, no light, that means it's a black surface. So we will get high or low lah. Bila high, that means there's a white surface. Bila low, it could be a black surface. Tapi depend on how you convert, how do you encode the signal. Okay, sometimes white is 1, sometimes white is 0. Okay, depending on the sensors. Okay, and then another sensor yang I think the most optimum sensor for the surface is actually light sensor. Okay, some people put a lot of sensor to detect more. Okay, some just use one. Okay, the more sensor that you have, the better. Okay, kalau macam kita design system ni, bila kita design mechanical atau robotic system, or even automotive system ataupun apa yang kapal terbang punya sistem kan, bila kita ada sensor based system, normally kita put redundancies. Redundancies ni maksudnya kita ada sensor extra lah yang kita letak supaya backup. Katakan kalau satu fail, then dia boleh guna sensor lain sebagai backup or etc. Or normally they use voting system. Kalau sensor semua beritahu okay, baru dia confirmkan okay. Macam kapal terbang, okay, wajib ada this redundancy sensors etc. So basically kalau nak cakap, kalau when you design a system, lagi banyak sensor, lagi banyak redundancies in the sensor punya the sensing, the better the robot will be lah, the more reliable it will be.
Doktor nak tanya?
Yes.
Boleh ke?
Boleh.
Okay, kalau colored surface macam mana doktor? Katakan merah ke hijau ke?
Okay, kalau colored surface, kita ada light sensor. Yang ni IR sensor kan, we can replace this with light sensor, and then light sensor, the way it detects color, dia letak filter, the light sensor, and they put a filter, whether red filter, blue filter or green filter. And then from these 3 filter, okay, artinya light sensor that detect red, okay, dia akan dapatkan the red color light lah, and then the green akan dapatkan green color light, the blue akan dapat blue color light. And from this 3 combination of lights, you can get any other colors. You boleh detect yellow, orange, etc. But you need these 3 three sensor with filter depan tu ada filter red, filter blue and filter green. And that is how actually our camera works. Kita punya kamera kan dekat phone kita. Jadi kita tangkap tu kan dia ada dapat 10 megapiksel ataupun 5 megapiksel, 2 megapiksel kan. One pixel is three sensors, which is red, blue and green. So from these three value you can create any colors. Macam screen ni, kalau kita tengok screen sekarang, okay, the way we create this white is by giving maximum color red, maximum color blue and maximum color white, dia jadi black. Okay, kalau biru ni mungkin ada component of blue higher. So that's how the computer generates this color from these three main coloring lah. So when you sense, you also sense these three color. Tapi ada juga kamera yang guna filter yang lain. Dia tak guna this RGB axis, dia guna the chrome, this Y yellow, Y RCB punya axis. Dia different color punya axis lah. But from that three color, you can also generate any colors. So you need these three untuk create this 3D color mapping of the whole thing lah. Alright, so that's how the color sensor. Tapi for this Sumo, sebab dia black and white, kita boleh pakai low cost lah. Maybe add redundancies, pakai banyak sikit IR sensors.
Ya, betul.
Lagi reliable the system will be.
Untung kita pakai black and white saja.
Better pakai black and white for this lah, for this particular problem. Sebab Sumo dia white and black kan.
Betul.
But when you go and do more complicated tasks, maybe you want to use color sensor as well. Okay, alright. Next is the object sensor. Okay, sama the way the sensor works is the same. Okay, one of the popular front-facing obstacle ataupun object detection sensor is IR sensor, where sama juga kita transmitkan IR. Okay, kalau tak ada object, then the IR will not bounce back to the sensor. Okay, tapi kalau ada object, the IR will be reflected back and the sensor will sense a reflected light. And this reflected light will tell the robot, okay, ada object kat depan. Okay, the problem with light is sebab light travels very fast. Normally when you have a light-based sensor, dia normally digital. Dia akan beritahu sama ada objek ataupun tak ada objek. You just set the threshold how far kan. Sebab light travel very fast, so it is very difficult to sense how fast, nak sense how fast does the light travels. Okay, tapi now you have a much more advanced sensor. The LiDAR, you know LiDAR kan? LiDAR is light-based detection sensor, detection and ranging sensor, where the microprocessor yang ada atas sensor tu is a very fast microprocessor where it can sense how fast the light travels. Okay, dia boleh sense light pergi dan reflected berapa jauh ataupun berapa lama. Dan daripada travelling time tu dia boleh calculate lah and what is the range. And this is a very reliable sensor yang kita pakai dekat banyak sistem sekarang lah. Kalau kita buat AGV dekat kilang, normally you'll have LiDAR, okay, to detect obstacle, surrounding obstacle, berapa jauh is the obstacle, etc. Bila macam Google autonomous car also use LiDAR to detect the surrounding of the car, ada tak objek, dan kereta very critical for the car to stop daripada langgar objek. So they're using this very expensive LiDAR sensors. Cuma for our case, macam kita we are learning, okay, for learning LiDAR ataupun light based sensor ni tak ada, dia tak boleh detect range, because to detect range from lights you need a very fast processor. Okay, so IR can tell you whether there's an object or not in front. Okay, cumanya there's an alternative sensor, okay, that we can use called the ultrasonic sensor. Okay, the ultrasonic sensor, instead of using light, okay, IR light ke, the colored visible light ke, the IR sensor use sound wave. Okay, they generate mechanical vibration, sound wave yang kita tak boleh dengar juga, sound wave yang out of our ear punya frequency range. Okay, dia transmit dan dia punya working sama, working principle of the sensor sama. Dia transmitkan sound, and then when the sound detect an object, dia akan bounce back. Okay, dan ada macam receiver, macam microphone base lah, ada microphone yang detect balik di sound wave. Okay, dia datang balik, kita akan detect. Okay, so that's how the ultrasonic works. And the good thing about this is sound travels much slower than light. Okay, so you don't really need expensive microprocessor ataupun really need expensive processor untuk time kan how long have the light travels. Okay, even Arduino Uno pun boleh measure how fast have the light travel. Cuma light travel very fast sebenarnya, very fast. It's Mach 3 kan, Mach 3 punya speed, which is the jet. Kalau dia pass Mach 3 dia akan ada supersonic kan, dia akan meletup. Ada sonic boom. Dia akan break the sound barrier punya frequency tu, dan ada sonic boom, and that could cause vibration. Cuma the point is light travel very fast but not as fast. That's why we can have a jet that travels at Mach 3 and etc. So light travels slower than light, and you can get a low cost sensor that can give you the range, how far is the object in front. So using this sensor, you boleh detect the range of the object. And kalau you boleh detect the range of the object, then it gives you more flexibility to your robot lah. Your robot can scan and then boleh detect objek tu jauh mana. Dan daripada situ dia boleh ambil tindakan yang seterusnya lah. Okay, so ultrasonic. Cara ultrasonic function is the ultrasonic have 2 pins. Ultrasonic yang kita akan pakai on motif, for example, yang ataupun yang standard that people use with Arduino have 2 pins. Dia ada trigger pins dengan dia ada echo pin. Trigger dengan echo. Okay, the trigger pin, what you have to do is you have to give a pulse as long as 10 microsecond. Okay, 10 microsecond. 10 microsecond ni very short tau. Tapi dalam program, dalam microcontroller punya duration it is not that long. Okay, dia microcontroller can do so many things in 10 microsecond. Okay, so you just generate this 10 microsecond pulse, and then drop to zero, drop to low. What that will do is it will tell the sensor to generate the pulse. Okay, dia akan generatekan this echo, the chirp. Okay, and then once the chirp comes back, okay, and it is detected, then this echo pin, bila kita transmit tu, bila dia habis transmit, echo pin akan naik high. Okay, dan bila dia detect oleh sensor tu, echo pin akan turun. So this echo, the duration of this echo punya pulse tells you how long have the light travels, how long have the sound travel. Okay, dan daripada situ kita boleh measure distance, which is the time taken, which is this pulse duration, okay, kali speed of sound, which is quite fast, 343 meter per second, divided by 2. Okay, and that gives you the distance of the object in front of the sensor. Okay, so ultrasonics is an alternative. Okay, dia punya advantage is it can gives you the range. Kalau macam light based sensor tadi, kalau you nak tahu range daripada light based sensor, mahal sikit lah. Okay, so yeah, that's ultrasonic. Okay, and this is another slide on ultrasonic. That's the trigger pin, that's the echo pin, okay, which you have to control. And this sensor, kalau kita guna H0SR04 ni, dia punya power specification, dia punya voltage is 5 volt supply. Okay, and dia ada angle sikit, sebab dia light, dia ada angle compared to kalau kita guna light yang more projected light. Okay, and the range distance can go up to 500 cm. And then dia punya sensitivity 0.3 cm. Okay, which is quite accurate juga lah. Okay, and the way you do it tadi, you bagi three signal, and then you'll get the chirp, and then you'll get the echo, you read the echo pin signal, okay, berapa lama duration dia, and then you can calculate distance. Alright, so that's the sensor of the sumo robot.
Sumo robot.
Okay, those yang you can boleh pakai dekat sumo lah. Okay, and also this object sensor, okay, some robots, okay, they deploy more than one. Okay, dia bukan kat depan je, dia pandang depan, pandang tepi, pandang kiri, pandang belakang semua lah. And kalau manusia pun, kalau kita boleh tengok what is behind us, okay, that actually gives you a lot of advantage. So kalau robot ni, you can design however you want. You can put the eye anywhere. Okay, you can put eye in front, to the left, right, and even at the back. Okay, so yeah, be creative in your robot design, as long as it works for you lah, and gives you the best performance. Okay, so that's a little bit about sumo robot design and the sensor. Okay, next, if there's no question, we'll move to a simple programming. Okay, I'll just demo quickly how we can program the motifs using M-block. Okay, but I will not be programming the whole thing, sebab you have been looking at M-block programming ni dari awal, daripada klinik yang first lah. So today we will just look at how we can use the ultrasonic, how we can deploy the ultrasonic on the M-block.
Boleh, betul.
Okay, ada persoalan, ada soalan?
Ada soalan daripada peserta? Kalau ada, boleh you write down you punya soalan ataupun kemusykilan. Ada doktor sekejap, daripada Nadilah. Okay, is this the kind of sensors that is used for autonomous vehicles, macam sensor kereta ke? Which is more commonly used for this purpose, light based or sound based?
Okay, kalau autonomous car, as I mentioned tadi, autonomous car would go with this more high-end sensor lah, the light based. Okay, light based LiDAR lah, LiDAR sensors. Okay, normally they'll have the 360 degree. Dia ada LiDAR yang boleh scan surrounding. Okay, even top and bottom tak adalah, top and surrounding lah of the car, to give awareness to the car, which is a big robot, what is around that car. Okay, kalau car ni very critically, dia tak boleh langgar orang, dia tak boleh langgar objek lah, apa-apa objek. Kalau langgar je, kereta tu akan rosak, so very expensive to fix, etc. So you normally have light based sensor. Sound based sensor, macam kereta banyak sebenarnya pakai light sound based sensor. Kalau you tengok your kereta kan, bila kita reverse tu ada bunyi yang tit kan, itu ialah sound based, dia guna ultrasonic. Itu ultrasonic sensor. Dia macam guna ping based lah. And it is quite reliable, being used dalam kereta, dalam banyak industri juga. Cuma untuk autonomous car, mainly the sensor yang mainly deployed is the light based, the LiDAR, to give the 3D awareness, and then also camera, banyak kamera untuk buat detection of the what is it surrounding lah. Bila di detect objek kat depan, kalau kita guna LiDAR, we don't know what is that object. Kita tahu ada objek tapi kita tak tahu orang ke, kereta ke, tiang lampu ke kan. Tapi what the car, the autonomous car normally have, they have the image processing punya sensor, camera, normally camera based, where they capture the image surrounding the car, surrounding the vehicle, and then buat detection or recognition what are the objects surrounding the cars. Okay, and from there they make decision lah how to move and how to avoid and when to stop, etc.
Rasanya doktor, kalau kapal selam banyak guna sound based.
Macam mana?
Kapal selam
dalam laut. Dalam air, memang normally we rely on acoustic sound. Sebab air, light cannot travel very well in water.
Ada soalan lagi doktor daripada Muhammad Fadli bin Sulaiman, ILP Kepala Batas. Berapa jauh jarak minima dan maksimum ultrasonic sensor boleh kesan objek?
There are so many kind of ultrasonic sensor ni, macam-macam. You boleh dapatkan dekat pasaran tu, banyak jenis ultrasonic sensor. Tapi kalau macam you nak pakai yang low cost, yang standard orang pakai on Arduino, okay, for example, kalau kita pilih yang ni, then dia punya HCSR04 ni, dia punya range ialah 2 cm ke 500 cm untuk sensor ni lah. Tapi you boleh dapat sensor lain yang boleh detect range yang you nak, lagi jauh pun boleh. Alright. Okay. So I think we can move on to the next session. Okay, I will be showing how we can program, simple program. Macam ni kita boleh program ni guna GUI base, kita guna M-block dulu. How we can program using M-block, the motifs, okay, tapi nak baca reading daripada ultrasonic. Okay. Sekejap. Before that, let me stop sharing sekejap. Yeah, I want you guys to look at my camera. Okay, so kalau tengok motif ni, okay, motif what you can do is you can take sensor, ultrasonic sensor, okay, this ultrasonic sensor, dan pasang dekat atas ni, boleh pasang cucuk terus, okay. Tapi for Sumo, sebab objek kita is 5 cm je tinggi dia. So kalau saya letak dekat atas robot, dia tak nampak. Sebab kalau objek tu kat bawah kan, dia tak nampak sangat lah. So I use this extension jumper wires, okay, untuk gerakkan ultrasonic dan letak dia dekat depan motifs. Okay, dia jadi macam mata tapi mata kat bawah sikit supaya dia boleh detect the object more effectively lah. What I would suggest to be done if I'm designing my Sumo robot lah. Okay, but again, you might have your own design decision yang lain daripada how I want to do it. Okay, but for this example, I'm putting the ultrasonic down, okay, so that I can detect the object which is lower. Okay. Alright, so going back to the screen. Okay, can you see the M block?
Boleh.
Okay, alright. So now we want to program our motifs robot menggunakan M block. Okay, the first thing yang kita dah buat banyak kali, I think daripada klinik yang first, is to add the extension make blocks. You look for make blocks. Look for motifs. Okay, dan kalau first time you download, you have to download first. You have to press plus, nanti dia akan downloadkan the library into your computer. Kalau dah pernah download, then you just choose and then click OK. Now you have access to all the make blocks punya block lah, ataupun function blocks yang kita boleh guna untuk program our robots. Okay, and for this, okay, I will not be lagi satu, my field pun ada problem sikit, dia punya reflectant of the surface is too high, so the light sensor kat bawah tu tak boleh berapa function elok. So I will be just demonstrating how to detect, how to read the ultrasonic sensor value. Okay, and then from there we make decision whether to move forward and push or not. Okay, simple programming je lah. Okay, so what we do first is we go to events again when make block, when motif starts. Okay, and what we want to do next is we want to detect the press of PB1. Okay, bila kita tekan PB1, then the robot will start. Okay, when we want to start the game, okay, say to the referee, okay, I want to start, and then you press PB1, and then the robot have to wait 5 seconds. Okay, so press PB1 to start, and then go to wait. Okay, go to control and put wait 5 seconds. Sebab kita nak dia robot tu tunggu 5 saat. Right? So now when you press 5 seconds, then the robots are free to do whatever it wants to do. Okay, so in my case here, okay, what I want to do is my Sumo robot will start from behind the Shikiri line, and then what I want the robots to do, okay, this is just a simple proposal lah on what the robot could do. You could have different kind of strategy, okay, how your robot should move. Okay, but for my demonstration today, I'll just make it very simple. Okay, I want my robot to first turn around, okay, look around, okay, scan around, whether there is an object or not. Okay, kalau ada object, okay, kalau the ultrasonic detect an object, then I will move forward and push that object. Okay, very simple demonstration. Again, I will not be sensing the ring. Okay, this demo will not be sensing the ring. Very simple one. Okay. So I want the robots to repeat this. Okay, repeat and repeat. Basically, turn around, look for object, and then push. So we do forever. Okay, repeat this forever. And what we want is, if there is an object in front, then we will move forward. So I put the if else there. Okay, or else turn around and look for object. Okay, so that's why if and else. Okay, so kalau ada object, if there is an object, okay, the diamond box is ada object. Okay, then move forward. Okay, I want the robot to run forward. Okay, probably for this demonstration I'll use slower speed. Okay, 50 and 50. And my motif actually ada problem sikit. Dia punya right motor tu laju sikit daripada left motor. So I make it run forward. Untuk dapatkan betul-betul forward, dia kena adjust sikit the speed 50 and 60. But this will make the robot move straight lah. Okay, kalau tak ada object, if there's no object, then what I want to do is I want to turn around, spin left. Okay, and also at slower speed, maybe 30 and 40. Okay, the robot will turn around and look for objects. Kalau ada object, dia langgar. Okay, how do we know there is an object or not? We have to use the sensor. Okay, the ultrasonic sensor, which basically comes from this motif sense. Okay, read ultrasonic sensor. Okay, but when you read ultrasonic sensor, you'll just get the value. Okay, so what you need is you have to operate on the value. Okay, go to operators. So kita kena compare. Okay, is the ultrasonic value less than 50? 50 is the range in cm, 50 cm. But for this demo, maybe I'll just put 30 cm lah. Okay, kalau the object is less than 30 cm, then I will go and push that object. So this is a very simple program that I can upload to the motifs and get it to push some object. Okay, any question about the programming, this simple one?
Setakat ni macam tak ada lagi.
Okay, alright. So let's continue. Okay, I will now program. Okay, I'll connect the motifs to the computer, to this computer, and then program it. Okay, click on connect. Okay, choose the COM port, and then press upload. Okay, now the code is already uploaded into the robots. Okay, now the robot can perform instruction that I have given, this instruction. Okay, this is my instruction that is uploaded into the microcontroller of the robot. Okay, when I turn on the robot will, the microcontroller or the brain of that robot will basically execute the instructions. Okay, again and again and again. So now let's quickly demo what we have programmed. Hopefully it works. I think the code looks right. Okay tak, Cik Kamal?
Boleh.
Okay, boleh?
Boleh.
Nampak okay. I think the code is okay. Okay, let me now. Okay, I have to move my camera. Okay, sorry.
Okay, jika ada soalan ataupun kemusykilan, boleh ya anda tuliskan soalan anda di Q&A dan kita akan cuba menjawab. Untuk pengetahuan peserta, kategori sumo, Robo Sumo, untuk advance kita buka kepada international juga. Jadi kita boleh kalau lah ada peserta daripada luar negara boleh join kita, kita dapat bertanding dengan mereka juga.
Okay, so yeah, can you guys probably can see the field?
Boleh,
Okay,
boleh.
This is the field yang dah print. Okay, I have printed the field. Okay, and I just sit there. Now I move here. Okay, the field ni kita print atas kertas A4. Okay, and you can see after you print, okay, you'll get everything. Okay, on the box, the measurement box semua ada kat sini. The measurement box. Dan kalau I take a ruler, okay, I measure, okay, you'll get exactly 15, okay, exactly 15 cm there. And this one is exactly 5 cm lah, sebab kita print on A4 according to the scale of the PDF file lah. Alright, okay, so now let's demo quickly. Imagine that the robot, okay, should start from behind the shikiri line. Okay, and I turn it on, and let's say the object is here. Okay, and when we turn this robot on, okay, what it would be doing is supposedly, if the programming is all correct, we'll turn around, and look for object. Okay, so what this ultrasonic sensor will find is this object, okay, which is less than 30 cm away from the robot. Okay, but before that we have programmed the robot so that when I press this, it will wait 5 seconds before it starts moving. So during the sumo game, you have to give a signal. Okay, say referee or jury, I want to start now. Okay, I will press. When you press this, you have to start your stopwatch at the same time. Okay, so you press, count 1, 2, 3, 4, 5. And the robot will start spinning and detect the object to push. Okay. Tapi, but again, the programming is very simple. It does not detect the ring, so it'll go out lah.
Cuma programming ni kita detect obstacle saja.
Yes, it just detect the obstacle, the
halangan saja.
Yes, and it will move according to lah. Bila detect object, dia akan gerak ke depan.
Gerak ke depan. Arahan kita bagi kepada robot.
Ya, cuma sebab sensor punya position, okay, sensor punya position only ke depan, so bila objek tu tertolak ke tepi sikit, dia kena pusing lagi untuk cari dan tolak. And then your robot, okay, should also be able to sense whether it is on the black or white surface. Bila dia tolak tadi, bila dia terkeluar patutnya, if you use the light sensor at the bottom of your motif, okay, bila detect white, okay, you should program the robot to reverse. Okay, and then look for other objects.
I see.
Right? So that object, since once you reverse, okay, the object will become very far, and the ultrasonic can tell you that it is how far is the object. So you'll go and find other objects that is in the ring, which is closer, okay, compared to the object that is outside. So probably that's the advantage of ultrasonic. It gives you the information of how far the object is compared to the IR sensor. All right. So so that's a very short demo about programming ultrasonic sensor on M-blocks. Any question?
Setakat ni tak ada lagi, doktor. Tapi cukup kita faham, kita menggunakan tadi kan, apa nama, programming secara M-block ya, doktor ya?
Ya, menggunakan M-block.
Menggunakan M-block. Doktor akan membuat programming secara tradisional juga.
Okay. The next one is to program using Arduino. Okay, but let me quickly recap lah.
Okay.
Nampak tak screen?
Nampak?
Okay, alright. So let me quickly recap. Okay, this the motifs punya coding tadi. So when motif starts, you program, okay, this wait for 5 seconds sebab kita nak meet the requirement of the rules of the game, and then you program your behavior. Okay, and normally this behavior is a repeating behavior, so you put it in forever blocks. Okay, and basically you would have more and more if conditions. Okay, if whether I'm on the black or the white line, and etc. etc. So all this behavioral programming have to be put in lah. Some other you use M-block to program, or some other you use Arduino to program. all those conditions have to be defined. All right, so that's programming the motifs using M blocks for detecting object using ultrasonics. So next, I will share back the slide.
Menggunakan robot motif juga doktor kan?
Ya, menggunakan motifs. Okay.
Motif juga.
Yeah. Motifs.
Pada sesiapa yang berminat dengan robot motif, boleh berhubung dengan Petroscience juga.
Yeah, motifs are being sold in front of Petroscience.
Yeah,
Petroscience punya kedai.
Yeah.
Okay, so next is programming the motifs using Arduino. Okay, Arduino can also be used. Okay, if you want to advance to learn something more advanced, you can try to program using the Arduino IDE, the text-based programming lah. And it is not that it is not difficult sebenarnya, but yeah, but you have to be more bila programming dengan line or text-based coding ni, you need to be more meticulous and you have to know more details. Okay, macam kalau dalam M blocks tadi, bila kita drag macam read ultrasonics kan, when I drag in this block read ultrasonics, I don't really need to program whatever we have discussed tadi kan. Ni trigger pin, echo pin, I don't have to define all this. Okay, I don't have to control the trigger pin, I don't have to control the echo pin. I don't have to read from the echo pin to know the duration, etc. Tapi when we go lower, okay, when we go lower to the C level punya programming instead of block-based programming, you have to give more. You have to know more details. Okay, that the details have to be absorbed in or have to be known before you can do the programming. Okay, kalau you nak lagi advance, you go to the assembly punya level programming, lagi complicated, lagi detail lah dia punya programming. But the more the lower level you go in programming level ni, programming language level, the more you will learn about how the processor really works lah. Okay, so now we want to look at programming the same robot but using Arduino. Okay, but we'll do similar programming. Okay, and to program using Arduino, okay, to program this robot using Arduino, what you would need to know is the pins. Okay, where do these ultrasonics sensors connected? Okay, which pin is it connected to? And then where do the motor is connected? Okay, which pin are the motors connected to? Kalau kita tengok motif punya pin configuration, okay, you can see all the pins. Okay, these are some of the pins. Okay, the more important one that I take and decide to show here, which is relevant to what we want to do lah. Okay, the first one is the motor. See all this from enable motor to the PWM motor. Okay, enable motor is when you give an enable signal, okay, you will allow the motor to move. Okay, when the enable signal is low, then the motor will not move. Okay, will stop. So in other words, the enable motor signal must always be high for the motor to move. And then you have motor A and motor 1A and motor 1B. Okay, and this A and B decides the directions of the motor. If you want to rotate clockwise, then you give low and high. Okay, in A high and low. In A high and in 1 high and 1 and 2 low, and etc. Okay, and then to turn left, you give the opposite. And then if you give the same signal at high and low, then the motor will stop. Okay, will not move. When you give the same both high, also will not move. Okay, so that's how you control the motor. And then to control the speed of the motor, we use the PWM signals. Okay, PWM signals is like a pulsating signals. Okay, the higher the value, the faster the pulse. And this pulse will go into the motor driver that we discussed earlier. And the motor driver will will basically gives more voltage to the motor if you give higher value PWM. Okay, lower value PWM, then you give lower voltage to the motor. Motor will spin slowly. So to control the motor, okay, kalau tengok M blocks, okay, very easy. Just drag this one block, and then decide on the speed, and then it will move forward. Okay, you don't really know that to move the motor, you need to control all these 7 pins. Okay, these are 7 pins that you need to program, okay, so that the motor will move forward or backward, fast or slow, etc. And then also to control the ultrasonic. Okay, the ultrasonic is connected to pin 14 and pin 15. Pin 14 and 15. I don't know if I do the programming from scratch. Okay, then will take quite a long time. Okay, but what I will quickly show about Arduino IDE. If you're not familiar with Arduino IDE, or if you've used Arduino IDE before but never programmed motifs with it, then probably this exercise will help you.
Doktor, sekejap Doktor minta maaf. Ada soalan daripada Muhammad Fadli bin Sulaiman daripada ILP Kepala Batas. Boleh tak kita setting pada program untuk jarak maksimum sensor ni? Sebab kalau jauh sangat, objek lain kat luar gelanggang pun dia kesan.
Boleh. Sorry. Okay. Probably to explain the answer to that question, what you can do kan kat sini kan, kalau object less than 30, then read ultrasonic sensor. In this case, okay, kita limitkan the distance to 30. Kalau you nak objek tu jauh lagi, then you can increase this. This value boleh jadi maximum 500 kan. So kita tak nak 500 tapi kita nak mungkin dalam 100 meter. 1 meter. Then you put 100 there. That's how you limit. Okay, and at the same time you can put the lower limit. Okay, you can put end condition ke. Okay, kalau objek tu berada in between 100 dan, for example, this is just example lah. Berada dalam antara 100 dan juga 100 ke 50. Kalau objek tu berada dalam 100 ke 50, then do something. Boleh juga. You can have this condition end. Okay, in your if condition.
Okay, Doktor.
So dia boleh limitkan dan dia boleh limit bawah dan limit atas. Okay, so continue to Sumo robot tadi. Okay, Arduino programming. Kalau if you're interested, Arduino programming, as I said, it gives you a lot of benefit, a lot of control to the robot. Okay, sebab you can actually control the robots by knowing the pins. You can actually control the motor, how the motor spin and how fast it's spinning and macam mana dia nak spin, semua you boleh control. Spin 2 saat, 3 saat ke, semua you can control from text-based programming. Okay, and what we need to know, what we need to do is when we do programming, okay, kalau Arduino programming, you have to be familiarized with the Arduino punya format. Okay, when you start an Arduino code, you will get these 2 functions. Okay, void setup and also void loop. Okay, the void setup, okay, will be executed once. It will be executed once, and then finish. The program will execute the loop. Okay, infinitely execute this void loop. Okay, so execute once and then execute in loops forever. Okay, the loop function will be executed forever. Okay, what this void setup for? Okay, this function void setup for is for us to do our initialization. Normally setting up the pins, okay, whether it is input or output, etc. And then maybe setting up our communications, okay, serial communication, etc. And do all this setting up. Probably the push button, okay. Kalau kita tengok dengan M block tadi, you have this push button. Okay, probably the push button can also be put here. And then in the loop, okay, this loop is like this forever loop. Okay, this forever loop. They can execute forever. So that's how Arduino, how you put your program in Arduino. All right. If I have to program everything from scratch, it will take quite a long time. So I've written this program in advance actually. So what the normal way to program an Arduino, okay, we will define all the pins. Okay, it is very difficult for me to remember that echo is 15, trigger is 14. Right? We have to always refer to this table. So what I normally what's the best practice to do is to define our pins. Okay, echo pin is the pin of my ultrasonic sensor. Okay, which is number 15. Kalau kita tengok table ni dia number 15. Right? You just define according to this table. So I define all the pins, okay, ultrasonic and the motor using according to the table. Okay, next in the void setup, okay, what I do is we declare whether the pin is an output or input. Okay, for ultrasonic, okay, which is echo and trigger pins, the echo pin is an input. Okay, kita akan baca echo pin untuk measure the pulse length. And then the trigger pin is the output. Kita akan bagi trigger to create the chirp, okay, to create the signal, echo signal, okay, and then to give this 10 microsecond signal so that the ultrasonic bursts the sound, okay, and then and then basically what we do is we trick, signal trick, and then read the echo pin duration. And this is input, and that the trick pin is an output to the ultrasonic sensor. Okay, this is an input to the microcontroller and output to the microcontroller. And for the motor, okay, everything is an input. Our microcontroller have to send signal to the motor, right, to the motor driver. So all of these are the output of the microcontroller. All right, and then probably we look at this. I created a functions to control to read the distance from the ultrasonics. Okay, this function distance. Okay, when I call a distance, then it will return the distant value. How far is the object? Okay, and then compare with 30. Is it less than 30? Okay, similar to the M-block programming just now. Okay, and if you look at the distance punya code, okay, it is actually very simple, following the flow diagram that we just have just now. Okay, kita mula-mula kita akan clear kan kita punya trick pin must be low, mula-mula low. We have to make sure that it is low, and then kita naikkan dia high. Kita naikkan dia high selama 10 microsecond, yang 10 microsecond pulse tadi kan. After 10 microsecond, then kita bagi low. Okay, very easy. In Arduino, you can create 10 microsecond pulse very accurately using this simple line of codes. Okay, and then after that, bila trick pin ni dah bagi signal, okay, we expect the chirp will be sent out from the sensor, and we quickly read the echo pin. Kita baca echo pin, okay, and measure the pulse length. Okay, we read the pulse length of the echo pin. Okay, and this pulse length gives us the duration, okay, duration of the pulse, and from that duration kita boleh ambil duration kali dengan speed of sound bahagi 2. Okay, duration, speed of sound bahagi 2, and then this gives you the distance, and distance kita return back to the function call, which is this distance. So kalau value of distance is less than 30, then we move forward. Okay, else we turn left slowly and cari objek lah. Sama macam make block tadi. Cumanya dekat sini lah. Okay, this is another one, probably a quick one. Move forward. How do you actually program the motor to move forward? Okay, you have to give all the signals. Okay, kita kena bagi ME high, and then kita kena bagi pin 1B and 1B and 2B tu low and high untuk move ke depan. Dan kemudian kita kena bagi speed, okay, speed dekat PWM pin, okay, dan speed yang kita bagi ni lah 50 yang akan dipas kepada SR dan masuk kepada sini. Okay, and similarly this one is left punya motor, dua-dua bergerak ke depan. Okay, direction dia sama, low and high, low and high. Okay, and then to move the motor to turn left, okay, I create this function left. Okay, you can see satu low and high, satu high and low, so that they spin, they turn around. Okay, so that's the functions, and this is the main program. And this similar behavior to what we see in the make block. Cumanya dia lagi detail lah. You can actually do fine tuning easily sebab you control every details of the robots. Okay, if I program this, okay, kalau nak program kita cocokkan the robots. Okay, dan motif ni, robot motif sebenarnya dia ialah Arduino Mega. Okay, so you choose Arduino Mega. Kat sini choose Arduino Mega. And then choose the COM, okay, so similar COM port which is COM4, and you upload. Okay, upload Arduino samalah. Dia akan compile and then dia upload to the Arduino. Dia akan beritahu how much of the flash memory of the Arduino Mega have been used. Program yang I write ni, this program, okay, even though dia nampak panjang sikit sebab ada function-function semua, dia just menggunakan 1% je daripada total programming space of the Arduino. So banyak lagi lah kita boleh masukkan. We can put in much more complicated robot punya programming dalam Arduino ni. Alright, if I run, then you will see the same thing lah. Cumanya when I turn on, sebab kita tak ada pin button tadi, dia akan terus berpusing. See, dia terus berpusing dan cari. Bila kita on, dia terus berpusing sebab tak ada pin. Ada masa lagi ke Encik Kamal?
Actually kita dah lebih kurang dah ni. Dah 3.20. Doktor, cuma satu je kalau ni. Kalau kita nak buat syntax tu, programming secara Arduino tu, perlu process flow, Doktor ya?
Process flow, yeah, you have to know the process flow lah.
Process flow.
You have to know how the sensor works, you have to know how the motor works kan. Then from there you can do the programming. Tapi banyak lah, we have all the controls. Kalau quickly if I want to show, okay, sekarang ni kita tak ada function yang tekan button dia akan pusing kan. So kalau kita nak masukkan, for example this is push button 1 kan, 49. So what I can do is I can define PB1 49 kan, pin 49. And then this 49, okay, by default the Arduino kalau dia any pin yang kita declare, dia akan declare sebagai input. So actually I don't have to do this, tapi just for the sake of the flow, kita define PB1 as input.
Yeah, reference kita.
So what we can do is kita boleh buat digital read PB1, okay, and then and digital read PB1. Then kita akan dapat value. What is the value or the state of button PB1. Okay, and what we want is we want to put, kalau digital read PB1 sama dengan low, okay, kalau kalau dengan high, that means kita tekan dia, then kita nak start the program. Okay, kalau tak, kita akan stay in the program. So what we can do here is I can put a while, for example, this rough coding a while if PB1 press, then we will break. Okay, kita akan break the while loop. Kalau dia akan tunggu dalam while loop sampai bila-bila. Okay, tapi sebelum dia break, kita akan letak delay selama 5 saat untuk dia tunggu 5 saat. So if I program this now, the motor, kalau kita sekarang ni, kalau saya on kan, kalau saya on motif, kita tampak motor dia terus berpusing. Okay, terus berpusing sebab kita tak programkan press button and wait 5 second. Tapi sekarang bila kita tambah this code, kalau upload, okay, dan uploading. Okay, so sekarang kalau kita on, dia tak pusing. Tengok, dia tak pusing lagi.
Selama 5 second.
Dia tak pusing lagi. Sampai saya tekan PB1, okay, saya tekan PB1. And then 5 saat, 1, 2, 3, 4, 5, baru dia pusing. Sekarang lah, basically guna line of code, you have so much versatility. You boleh letak your condition dalam setup, dalam loop or any place lah. And then you can create functions, banyak versatile lagi lah. And you can access so many other senses of the motifs ataupun robot yang you build. Okay, I think that's all. Okay, probably quite text-based programming ni mungkin some might not want to know it yet.
Yeah.
Okay, tapi it's a good time. When you learn about
Yeah.
robotic, programming is always the key lah.
Yeah.
And
So, dia
programming
agak
move from
technical
UI to text based.
tapi amat penting Dr. ya kalau nak belajar programming secara
Sangat penting.
technical.
Sekarang ni AI semua tu, bila kita cakap pasal AI kan, pasal image processing, everything text based punya programming lah.
Text-based
Language yang popular C dan Python. Python is getting very popular lah.
Ya, faham.
So it's a good time lah, good time.
Baguslah. Doktor, kita dah sampai 3.25 sekarang.
Okay. I think
Doktor
that's
nak
all.
summarize?
Thank you so much.
Doktor nak summarize tak untuk ni wrap up Doktor punya?
Okay, so if I want to wrap up, okay, memang dah habis lah slide. If I want to wrap up quickly, okay, we have gone through today. We have looked at Robo Sumo, okay, and from this Robo Sumo, how design of robot ni, and then the electronic design, and then the programming, also the mechanical part, okay, will help you to learn about robotics. Okay, it's a very useful tool to learn about robotics. Okay, and again, a very important component of building a robot is the programming. And maybe we now starts with GUI based programming. Later on, probably we can push ourselves to move to the more advanced coding and programming lah. Okay, but again, any level is good actually. As long as you start with something. Okay, thank you so much.
Terima kasih banyak Dr. Yasir, terlampau banyak sebenarnya ilmu yang dikongsikan, dan juga kita harap dapat membantu kepada penonton ataupun peserta RBTX, dan juga yang penting adalah kita banyak knowledge dalam coding ataupun programming, terutama dalam robotic video learning. Jadi saya ucapkan terima kasih kepada Dr. Yasir, Yasir Muhammad Mustafa daripada Universiti Islam Antarabangsa kerana sudi bersama-sama kita pada petang ni. Dan sebenarnya episodnya episod terakhir, jadi saya nak ucapkan saya nak memberi penghargaan kepada semua ataupun barisan pakar penasihat robotik kami yang menjayakan program RBTX Klinik 2021 ini. Mereka adalah TS Dr. Zulkifli Mahmudin ataupun kita kenali sebagai Cikgu Zul, Abang Robotik lah ya, bukan Pak Cik, Abang Robotik daripada Universiti Uni KL BMI Gombak, dan juga kepada Profesor Madya Dr. Zulkifli Zainal Abidin daripada UIA Gombak, Profesor Madya IR Dr. Nurul Hazlina Nordin daripada UMP Pekan Pahang pun ada bersama kita dekat hari sini, masa ni Dr. Nurul, dan kepada Profesor Madya TS Dr. Yasir pada petang inilah bersama-sama kita. Jadi saya harap kepada semua penonton ataupun peserta, sila layari Petrosan website dan klik pada Virtual Petrosan RBTX Challenge, dan jangan lupa sertai kami. Masih ada masa sebelum 15 Oktober 2021. Jadi sebelum tu, Fana nak share QR code?
Cik Kamal, pendaftaran percuma kan?
Pendaftaran percuma.
Pendaftaran ialah percuma. So bolehlah ramai-ramai register.
Yang penting kita dapat belajar. Contohnya macam Dr. Yasir dah beritahu tadi, daripada M-block kan kepada teks punya programming, iaitu syntax. Ya. Okey, kepada semua peserta RBTX Klinik episod 8 ini, kami berharap dengan kerjasama anda untuk scan QR code ini dan menjawab ataupun mengisi evaluation form yang kami sediakan. So ada apa-apa lagi kata-kata daripada Fana? Ini episod terakhir Fana. Dr. Nurul? Tak dengar?
Dah unmute.
Unmute.
Tapi dah unmute dah.
Dah unmute tapi tak dengar. Fana? Fana pun tak dengar. Okey, dengan itu kita sudahilah kita punya program pada petang ini. Jadi kita berjumpa pada RBTX Challenge untuk 2021 qualification dan juga grand final pada Disember 4 dan 5 Disember insyaAllah.
InsyaAllah.
So sekian, terima kasih. Selamat berjumpa.
All the best semua. All the best semua.
All the best semua kepada peserta.
Okay.
Terima kasih.
Have fun.
Terima kasih semua. Terima kasih Dr. Nurul.
Terima kasih.
Terima kasih.
Terima kasih. Assalamualaikum, salam sejahtera.
Okay, Assalamualaikum.